So in these models, uh, how many data? No, just how many data points are there, and how many tuning parameters are they? I mean, I mean, is that a simple question, or is,
There are 30 vertical levels at least, and the resolution may be 2.5 by 5 degree grid or 5 by 5 degree grid. It's a huge number of data points.
It's more than 100,000 points.
Yeah, it's a jillion. And you should answer that question. And what was the second question? Oh, God. There's a paper by Gavin Schmidt. Have you seen that one on model tuning? I thought that there were just about 3 or 4. There are dozens. You can get any answer you want. And remember, as Hordan said, the Hordan paper was written by 14 different climate modeling groups, by the way. So those people who wrote that paper, the heads of all those groups, had to agree with the term anticipated acceptable range. So those models, there are an incredible number of parameters to make sure that it stays within the anticipated acceptable range. I'll get to you in a second. I got one more question. If you don't believe that, go back and find the Vucin article in November 2016 Science Magazine, because in getting the models ready for CMIP 5, each group has to submit what they call a frozen code model. And the Max Planck Institute in Germany, they had theirs ready to go. The head modeler there, Ernst Rechner, was indisposed and couldn't work on it. And so it was left to the senior other people and the postdocs and all that to get this model off to the U.S. government so it could go in the next IPCC report. And it was a darn good model, and it had 7 degrees of warming in it. And if you read the article, they actually say, we had to get that number down. So this isn't science. It's not. Sorry.
so that 7 degrees of warming, it's actually some extra data that you're putting in to fit. You're going to make the model.
What they did is they changed the way that heat diffused into the ocean, and there were some cloud parameters that were changed, right?
That was proven wrong, too.
Yeah. Oh, well. But on it goes. Dr. Bloom from SLAC.
How does the Russian model do on the ground data?
It does quite well. It's not great, but it's certainly better than what you have here. I would prefer a different flavor of that question. How does the Russian model do what it does? The heat capacity of its ocean is twice what it is in all the other models. So it takes more of a change in joules to move the temperature of the ocean. It takes twice as many joules to move the temperature of the ocean, the same amount. Now, why was that done? I don't know. Do you know, Volodin?
No, I've known, but I don't know what they did to it.
Because we don't know it.
Exactly.
Because it's deep. Nobody's been there. It's,
Well, not really. I mean, as he says, it's something that you have a range. So when you have a range, you can use the lower range and get a lower result. But it's very interesting that the study that this slowdown of global warming around 2000 to 2016, there was a paper in Nature that attributed to that the oceans absorb more of the heat that was generated in the 80s and 90s. It was proven that that was fabricated. And it was actually removed by nature.
yeah, that was.
You know that?
Oh yeah. I remember that one.
Oh,
Raswamy.
I don't remember the title.
I think Raswamy. Look it up. Just nature withdraws ocean heat
It
paper.
was retracted by nature itself, not by the authors.
The proponents of the climate change and getting warmer also think
It is getting warmer.
but
Yeah.
they make the point that this is affecting the oceans with the increase in the acidity, which is affecting the life of them. What do you have to say about that?
The acidity of the ocean varies so much in places with complex biological communities that I don't put much stock in that. I mean, it's kind of like acid rain. Remember acid rain? That was supposed to kill the forests and all that. Well, rain is naturally acidic, and nobody could really ever find these large effects, and a lot of money was spent looking for it. Maybe it should be called half acid rain.
But there is no doubt that the oceans are getting more acidic.
They are.
They are getting
Well,
more
they're getting
acidic.
less basic.
Yes, yes, okay, fine.
The problem with the ocean acidification is the experiments are done are lab experiments. You bring an organism into a lab, put it in an aquarium, and change the pH. Not quite the way things work in the real world. The ocean is not an aquarium, and very subtle to find any real effects so far. Although I have predicted that ocean acidification may be the next global warming. Yep. Yes. Yeah, we're way out of my field. You're in your field.
Yeah, there is a. Hello.
There you go.
The ocean does have a buffering capacity. It's a bicarbonate feedback system. If you put more carbon dioxide into the water, the pH can stay the same to a point, unless you overload that buffering capacity, in which the pH will begin to change. This is also highly dependent on water temperature. Whereas in warmer water, the carbonate can be more bioavailable, it can be pulled out of the water more easily than in cold and Arctic regions. It's one reason why you see big conches in the tropics, and if you go into the Arctic, where things like snails have shells that are paper thin.
Can I tell you how much we know about the ocean? You probably saw this. Basically, the climate models, which of course are never run, are calibrated all the 20th century. The general consensus is they predict the ocean circulation would slow down. That's where you get these stories of the climate of Great Britain turning into Siberia in a paper that was written by the Defense Department, which is never, ever self-serving. But turns out the ocean circulation is speeding up pretty much globally, completely opposite. And yet you want to predicate your society on the forecast made by those models. That endangerment finding is based upon documentation for the future that is only based on those climate models. That's all they have. You want to do that? Go right ahead.
I'm just going to make one point on the ocean circulation issue. That the idea that global warming could lead to a massive cool down of places like Britain is really based on one major ocean current, and that's the current. It's called the Atlantic conveyor belt. And what happens is when the Arctic gets very cold and fresh water freezes and turns into sea ice, that the remaining water is super salty, and that super salty water is dense and it sinks. And that's the driver of this conveyor belt. And that super salty cold water from the Arctic Ocean sinks, goes goes southward along the ocean floor, and then resurfaces near the tropics. And it pushes a number of currents around the world. And so that the discussion about global warming, melting the ice caps, creating large pools of water in the Arctic, that could theoretically slow down that conveyor belt because it's slowing down the push. If there's large pools of fresh water in the Arctic, then it's not going to create the super salty, dense water that sinks. Now, if you look at the ocean globally, there's hundreds of currents, some more important than others. And so, I just want to be I just want to make sure we're taking in all available facts within, within our that are available to us in our means to retain them and understand them. But I know I saw an article and I just read the headline. I'm guilty of my own talk here. I did see that article that ocean currents are being sped up, possibly because, but that's not. Like, let's remember that's not all currents.
Oh God, did you see the map in the article? It sure looked like damn near all of it.
So, see, I guess that's where maybe we'll just agree to disagree. I have a hard time believing that every ocean current is being sped up. And I think this is that sort of what I was speaking to, and talking about the red dots and stuff that doesn't quite make sense. I mean, are we really making efforts to take in all available facts and to refine our theories? I see predictive models. How much time we got? I got a good predictive model story.
2 minutes.
Okay, this one will come later. Ask me about it later.
Well, and by the way, this the currents intensity increasing just came in today, so I was just showing the news. I haven't had a chance to read it.
Given the more and more data that we have, it's my intuition that people are looking at this data and seeing things they've never seen before and interpret them negatively. So we have more data, we don't have a bigger perspective, so we say, oh my God, we now see this, what's this going to lead to? And as a result, a lot of projections are put onto data that beforehand we wouldn't even have cared about.
I wonder why that would happen.
And do you mean by projections, you're projecting your own beliefs and your own biases and your own sympathies on them?
Stories, whatever. So we have more data that to project stories and fears on.
Did you know that if you take, I published on this actually, if you take a large sample of major journal articles, I'm looking at Science and Nature, and seeing it is the professed belief of my community in a friend amicus brief in Mass v. EPA, that there is an equal probability that any new science finding in global warming will make things appear to be either worse or not as bad as we thought. That is their statement.
But what's the middle way here?
And so that turns out to be a testable hypothesis. And I tested it, and the assumption of equality of that was so violated. It was violated with a probability of 1 divided by 1 followed by 17 zeros. I don't know what that is, but that's a big number. That's more than the number of stars in the universe, I think.
It's more than the seconds in the lifetime of the universe.
Yeah.
I guess we are out of time unless you want to stay here. Okay,
So,
last one.
Just one, and please don't shoot the messenger because I'm an environmental lawyer, and so I actually have to operate in this world of politics and public accountability in Berkeley, in Northern California, Democrat no less. So where you had me with this conversation was where the data got tossed. Data that was inconvenient got tossed. That's a very compelling legal fact. Is there any other area of science in this century or the last century where we have taken accurately measured data and just tossed it because it doesn't fit a theory? Is there a parallel?
I don't know, Sam. I mean, I don't know. I feel like
those data are less likely to see the light of day, let alone see the light of day and then be thrown out.